Join me as I dive deep into the mind-bending world of time loop theories and try to uncover if they're really real, just like John Wheeler said. You know, time loops, the idea that we relive the same moment over and over, it's a concept that's fascinated humans for centuries, and one physicist who's had a profound influence on our understanding of time is John Wheeler. This man's theories have shaped the way we think about the fabric of space-time, and today, we're going to explore his ideas on time loops and whether they might just be real. One of the biggest challenges in understanding time is that it's a complex and multifaceted concept. Our brains just aren't wired to fully comprehend it. When we start talking about time loops, things get even more complicated. You see, if time loops are real, then that raises all sorts of paradoxes, like, what happens if you try to kill your own grandfather before he has children? Would you still exist? Or would you be erased from existence? These kinds of questions are mind-bending, and they've been debated by physicists and philosophers for ages. Time is a dimension that's both flexible and rigid at the same time. It's hard to wrap our heads around that. If you start playing with the idea of time loops, you quickly realize that the rules of causality start to break down. It's a real brain twister, and even the smartest minds in physics have struggled to come up with a consistent theory that explains how time works. Another problem we face is that our understanding of time is largely based on our experience of it. We move through it in a linear fashion, one second after another. But what if that's not the only way to experience time? What if there are other ways of moving through time that we can't even imagine? These questions are at the heart of Wheeler's theories, and they're what make time loops so fascinating. John Wheeler was a pioneer in the field of quantum mechanics, and his work on black holes, quantum gravity, and space-time geometry is legendary. But what's less well known is his fascination with time travel and time loops. In fact, he believed that time travel was not only possible, but that it could be used to explain some of the weird phenomena we observe in the universe. Wheeler's theories on time travel are based on the idea that time is an emergent property of the universe, rather than a fundamental aspect of reality. In other words, time is something that arises from the interactions of particles and fields, rather than being a fixed background against which everything else happens. This idea leads to some pretty wild implications, like the possibility of closed time-like curves, which are essentially time loops. According to Wheeler, if we could create a wormhole or a shortcut through space-time, we could potentially use it to travel back in time. But here's the thing. If we did that, we'd be creating a closed time-like curve, which would essentially be a time loop. And that raises all sorts of questions about causality and free will. It's a complex and mind-bending idea, but it's one that Wheeler was convinced could be made to work. One of the most compelling insights that Wheeler had was that time loops could be used to explain some of the weird phenomena we observe in the universe. For example, have you ever heard of the bootstrap paradox? It's a situation where an object is sent back in time and then used to create itself. Essentially, it's a chicken and egg problem. Wheeler believed that time loops could be the solution to this paradox, and that they could even be used to explain things like the origins of the universe. Another area where Wheeler's theories on time loops are fascinating is in the realm of quantum gravity. You see, according to general relativity, gravity warps space-time, and that warping can create closed time-like curves. Wheeler believed that these curves could be used to create a kind of quantum gravity engine that would allow us to manipulate time itself. It's a pretty wild idea, but it's one that has been explored in recent years by physicists like Kip Thorne and Roger Penrose. Wheeler's most famous experiment that suggests time loops could be possible is the delayed choice thought experiment. Essentially, it's a thought experiment that shows how the act of observing a particle can actually change its behavior, even if that behavior happened in the past. It's a mind-bending idea, and it has some pretty profound implications for our understanding of time and causality. Wheeler's theory of time loops has some other weird implications, like the idea that the universe could be cyclical, with periods of expansion and contraction that repeat indefinitely. It's a pretty wild idea, but it's one that has been explored in recent years by physicists like Roger Penrose. So what have we learned about time loops in John Wheeler's theories? One thing's for sure. Time loops are a complex and fascinating concept that challenges our understanding of time and causality. Wheeler's ideas on time travel and closed time-like curves are some of the most compelling insights into this phenomenon, and they have some pretty wild implications for our understanding of the universe. Thanks for joining me on this journey into the mind-bending world of time loop theories. If you've got any thoughts on the subject, be sure to leave them in the comments below. And if you want to explore more mind-bending ideas, be sure to check out my video on time travel. The link is in the description box below.